In this video, we're going to talk about solving quadratic equations by factoring. So let's solve the equation x squared equals negative 3x plus 10. Now, what you don't want to do is try to take a square root of both sides. It's just not going to work out trying to do it that way. What we want to do is gather all the terms on one side of the equation. So let's add a 3x to both sides and subtract 10 from both sides. What we'll get is x squared plus 3x minus 10 is equal to 0. Okay, we want to find what value or values of x can we plug in that will make this true. And what we're going to do is factoring. Okay, so we're going to try to write the left side as a product of two factors so that when you multiply these out, when you FOIL these out, you get the original expression on the left-hand side. And the way we can do this for this problem is we can let x be here and x here. So x times x gives us an x squared. Now we want to find two numbers that multiply together to get negative 10. And so, for example, we could do a 1 and a 10 or a 2 and a 5, but one of those would have to be negative. But then we also want to end up with a 3x. So again, this is a bit of trial and error when you do this, but I think what could work for this one, what will work, is doing x plus 5 times x minus 2. Because notice, if we FOIL this out, we get x times x is x squared. We have a 5x from the inside two terms and a negative 2x from the outside two terms, so that gives us 3x. And finally, 5 times negative 2 is minus 10. Okay, so what values of x make this be true? Well, if x is negative 5 or if x is 2. Okay, we have two solutions, negative 5 and 2. Because if you plug in negative 5 for x here, we'll get 0, and you plug in negative 5 for x here, you won't get 0, you get something, you get negative 7, but 0 times whatever that is, 0 times negative 7, ends up being 0. And same thing when you plug in 2. If you plug in 2 for x here, you get 0. If you plug in 2 for x here, you get 7, but 0 times anything is going to be 0. So those are our two solutions. Now, one thing I want to point out with factoring is you almost have to get a little bit lucky. The problem almost has to be a little bit rigged up in order to be able to factor something. Not everything is factorable in a nice way. So if you were trying to factor x squared plus 7x plus 19 equals 0, if you're trying to factor that left side, I don't think there's a nice way to factor that. You can try to do it, but there's no nice way to do it without using a bunch of square roots and things like that. So not everything is factorable, but these problems where I'm asking you to factor, obviously they're factorable. Okay, now this one has 3x squared plus 11x equals negative 10. So let's add a 10 to both sides. So we get 3x squared plus 11x plus 10 equals 0. And now we want to factor this. But this time, notice we can't just put an x and an x, because x times x is x squared. We need a 3x squared. So we're going to have to put a 3x and an x. So if we multiply those together, we get 3x squared. Now we need to multiply two numbers together to get positive 10. So we could do 1 times 10 or 2 times 5. That would give us 10. Now minus 1 times minus 5, or minus 1 times minus 10, or minus 2 times minus 5 would also work, but we don't want to use those because we want to end up with a positive 11x in here. So let's see. I think now the one thing you have to be careful of is the number that you plug in here is going to get multiplied by 3x, whereas the number you plug in here is only going to get multiplied by x when you FOIL it out. So what I think we can do here is plug in, I think it's going to be 5 and 2 that are going to work, and I think if we plug in the 5 here and the 2 here, it will work. So let's just check this out in our head. If we do 3x times x, that gives us 3x squared. Notice multiplying the two inside terms, we get 5x. The two outside terms, we don't get 2x, we get 6x, right? 3x times 2. So 5x plus 6x, notice that's 11x. And finally, 5 times 2, that's 10. Okay, now how do we solve this? Well, we're going to have to set 3x plus 5 equal to 0, and then set x plus 2 equal to 0. Well, this one's easy to solve. X is going to be negative 2. This one, though, let's subtract 5 from both sides. We get 3x equals negative 5. And finally, divide both sides by 3. We get x equals negative 5/3. Okay, so we have two solutions, negative 5/3 and negative 2. If you were to plug those numbers in for x, so plug in negative 2, let's say for x here and here, you would get a true statement at the beginning. And same thing with negative 5/3. Okay, let's do another one. Now notice this one involves t, okay, not x, but that's okay. It doesn't matter what letter you use. And again, notice we have a 2t squared rather than just a t squared. So if we FOIL this out, we're going to have to use a 2t and a t. Okay, now luckily there's only one way to multiply two integers to get 13. It's just 1 times 13. Well, you could also do minus 1 times minus 13. And in fact, I think that's what we're going to have to do because we need to end up with a minus 27t. And I think what would work after doing a little bit of trial and error is if you put the minus 13 here and the minus 1 here. I think if you FOIL that out, you get the left-hand side, because notice 2t times t is 2t squared. We get a minus 26t from the outside two terms and a minus 1t from the inside two terms. So minus 26t and minus 1t gives you minus 27t. And finally, minus 1 times minus 13 is plus 13. Okay, now we could set these equal to 0, set the two factors equal to 0. T minus 13 equals 0 and 2t minus 1 equals 0. Well, over here it's pretty obvious what our answer is. T is going to be 13. Here, if we add 1 to both sides, we're going to get 2t equals 1. And then we divide both sides by 2, we get t equals 1/2. Okay, so we have two solutions again. T equals 1/2 and t equals 13. Both of those you could plug in for t and you get a true statement. All right, let's do one more. And this last one, notice we also have a 6x squared instead of just an x squared. And in fact, this one's a little trickier because 6 is not a prime number like 2 and 3 were. We could either do a 6x times an x or a 3x times a 2x. Okay, and it's not always clear how to do this. Should we put a 6x here and an x to give us 6x squared, or a 3x and a 2x to give us 6x squared? Well, fortunately, this number in the end, 7, is a prime number, right? There's only one way to multiply numbers to get 7. It would be 1 times 7, or of course negative 1 times negative 7. But notice we have a positive 23x, so I think we're going to put a plus 7 on one of these and a plus 1 on the other one. So the question is, should we put a 6x and an x, or an x and a 6x, or a 3x and a 2x, or a 2x and a 3x? It's a little bit of trial and error. But after thinking about this, I think you can see that if you put 2x plus 7 and 3x plus 1, I think that's going to work, because 2x times 3x is 6x squared. The 7 times 3x is 21x. And then the 2x times 1, that's another 2x. So 21x and 2x, that gives us 23x. And finally, 7 times 1 is 7. So that works. Okay, so let's set these factors equal to 0. 2x plus 7 equals 0. 3x plus 1 equals 0. So this would be 3x equals negative 1. And so x is negative 1/3. Okay, that's one solution. The other solution is we could subtract 7 from both sides and get 2x equals negative 7. And so x equals negative 7 over 2, or negative 3.5. So we have two solutions again. Now, just as a reminder again, not everything is factorable. Sometimes you'll have an expression like this and you just keep trying over and over and over again to try to factor it, and it's just impossible. There's no way to do it. It just doesn't work out right. And so in that case, you'll end up having to use the quadratic formula. Okay, and that's what we'll do in the next video.